Here we go, part 2 of improper integrals. So we're looking at the integrand versus the limits of the integral. So this part 2 looks at a discontinuous function in the integrand. And in this case, it's clear, I look at the denominator and it's just discontinuous at x equals 1. So that's where I want to split this up. I want to split up my integral at 1. So I'm going to look at the integral, what's happening from 0 to 1 of x cubed minus 1 all over x minus 1 dx. And then I want to look at what's happening from 1 to 2 of x cubed minus 1 over x minus 1 dx. So the other piece of this that I want to make note of is that limit at 1 in the first integral is really not valid because I know that x cannot equal 1. So this is where I bring in my limits. I'm going to replace the limit with a variable. So I'm going to say the limit as a, let's call it a, approaches 1 from the left of the integral from 0 to a of x cubed minus 1 all over x minus 1 dx plus the limit as a approaches 1 from the right of a, the integral from a to 2 of x cubed minus 1 all over x minus 1 dx. Now, as long as I have a limit that is valid, 0 and a and 2, I can use direct substitution, right? I'm not going to get a 0 in the denominator. And I can also factor and eliminate that common factor, which, if I remember the difference of 2 cubes, I can factor that x cubed minus 1. So let's just recall here, x cubed minus 1 is really factored to be x minus 1, the quantity x minus 1 times x squared plus x plus 1. So I'm going to rewrite my numerator, I'm going to factor and eliminate that x minus 1, and then I'm going to go from there. So next page. The limit as x approaches, actually, you know what, it's really supposed to be a, sorry, as a approaches 1 from the left, from 0 to a, and now I factor the numerator, canceled out that x minus 1, what's left over is x squared plus x plus 1 dx plus the limit as a approaches 1 from the right side. Again, I factored and eliminated a, that's an a, to 2, and what's remaining is x squared plus x plus 1 dx. Right, so now I'm going to integrate, evaluate, find the limit. I evaluate the limit, sorry, not really evaluating the limit, I'm just taking the integral, x cubed over 3 plus x squared over 2 plus x between a and 0, 0 and a, still the limit a approaches 1 from the left side plus the limit as a approaches 1 from the right of x cubed over 3 plus x squared over 2 plus x between a and 2. So let's now go that next step and plug in a cubed over 3 plus a squared over 2 plus a, and then everything else turns to 0, right? And that's the limit as a approaches 1 from the left, plus the limit as a approaches 1 from the right of 2 cubed 8 thirds plus 2 plus 2 minus a cubed over 3 plus a squared over 2 plus a. And it's that whole limit. And now I can use direct substitution. 1/3, so I evaluate the limit by using direct substitution. 1/3 plus 1/2 plus 1 minus 0 plus, well, I've got 8 thirds plus 4 minus, make sure I get everything intact here, and what do I have? 1/3 plus 1/2 plus 1. Oh, that looks familiar. And what can I do? This and this cancel each other out, so I really have 8 thirds plus 12 thirds, right? This is just 12 thirds, which in the end, final answer is 20 thirds, so it converges to 20 thirds. Alright guys, we are going to work on these tomorrow, and let's see, tomorrow's Wednesday, so Wednesday, Thursday, we're reviewing as we go. Remember, Friday is our quiz. Alright, see you tomorrow.